Excellent. Then it's all yours, Damian. Take it away. Thank you.
Super, fantastic, and thank you all for joining me on this presentation for infrastructure code. We're going to focus on specifically best practices with Azure templates. My objective here really is to share learnings from how to actually build templates and use templates in ARM based on real world experiences. I'm going to spend some time in the deck, some time on the actual environment, just showing you how these things translate and how to structure yourself. I'll try and speak at a pace that's not too fast. If I'm going too quick, please interrupt me, raise your hands, and I will jump down and slow down. And similarly, if you have any questions, please feel free to interrupt at any point during the session. Okay, so with that, let's start with a statement. Building production grade infrastructure is actually hard. Actually, it causes you to lose your hair follicles, and it takes a whole lot of time. The reason behind that is because building this stuff, we have to make sure that it is repeatable, consistent, and testable. We need a North Star to make sure that we can address those. And that North Star is very simple. Whatever we do in code. The problem statement that we've started with is the problem statement we always end with. How do I know what you've deployed? How do I know what you've deployed is consistent? And how do I do this consistently across environments or customers or whatever the scope it is that you're working on? That challenge is really, really hard, specifically based on the fact that we spend the vast majority of our time actually trying to get stuff done rapidly. So the idea of converting the easy process of point and click with a mouse becomes extremely challenging when we think about the idea of we need to actually convert stuff back to code. Everybody spends time inside their portals or inside their administration consoles, use their mouse and do the provisioning, the configuration, the troubleshooting, the testing. All of these habits we've built over time, we've done every single one of those using the tried and tested methodology. Get in there, sort it out. We cannot afford to be down in production. But the reality is, if we're going to scale, we have to actually flip the coin over and start dealing with every one of these entities as some sort of code. What I'm going to cover in this session is essentially the process of getting you started with the very best of practices. These practices have been found simply by getting it wrong. Trying something, realizing that it wasn't scaling, and then making some changes to the approach, and then working through those. The other reality that kicks in here, and I will echo throughout the presentation, is that most of the practices we're going to talk about, you will see blogged around the world, but in 90% of what I've seen, those blogs are based on a person doing a solution to a environment. So there is no concept of team or there's no concept of scale in any one of these. Certainly they'll speak to those, but the reality is they definitely have not actually architected to address those. And that's one of the things that we're going to try and deal with as we go through this. We're going to address the concepts that everything we are doing here needs to be approachable and acceptable by a team of people and multiply out to multiple types of environments. My name is Damian Flynn. I am joining you today from the west of Ireland. So I want to say thank you very much for giving me the opportunity to join you in Bergen. I think the last time I spoke was at the Booster Conference, and that's probably just over a year ago. My role has really been with InnoFactor for the last 3 years. I am product owner for our governed virtual data center technologies, which is essentially an infrastructure as code delivery, among other things. And I'm part of the core team that delivers and builds this architecture. I'm also a newbie to the world of consulting, spending most of my career actually inside the enterprise and running real world. My hat has been both as a developer and as an infrastructure operations. I've spent some time with security and also been responsible for global networks. So I'm pretty rounded in some of the challenges that we see as we try and pass the baton between the different groups. And it is that I'm hoping will bring forward to essentially taking my objective of trying to make this technology simple to understand. So what we're going to look at is infrastructure as code. That's the driver here. Infrastructure code is an approach for defining computing and networking infrastructure through code, just like any other software system. Martin Fowler is probably the father of infrastructure as code, as in making it real. Has a book published with O'Reilly and covers a lot of the patterns and practices that we're going to be covering today. Most of his focus, however, falls short of some of the stuff that we try to do in Azure. And specifically, the focus I'm looking at from the pipelines is around Azure. However, as with any infrastructure approach, if you happen to be a Punami or a Terraformer, there are many different approaches here that will follow through. Some will be much easier in those toolings, some will be more difficult. If you are using any of those other tools and are curious, please again raise your hands and let me know. So why? Beyond the first statement of we're doing infrastructure as code to simply make it easier for us to make sure we have a consistent delivery, what else are the drivers here? Well, the first 5 or 6 that always come to mind is automation. The idea is very simple. If I'm working in an enterprise, if I don't have to do the task and a machine can do it, then I'm saving that enterprise money. If I'm working in a consulting team or a managed service partner, then if I can automate the process, it means I know that it's going to be done consistently. That process is something that nobody else now needs to do, and it's repeatable. But the problem is processes don't sit stagnant. That's one of those utopias where people read about the flow and say, right, we've it done, everything's great. But the reality is that has to change. Everything changes. So version controlling becomes the next really important piece. And this is an absolute godsend from an IT perspective because it's not something that ITs generally do. Why? Because now I can do code review. The idea of making a change to configuration and having it blessed by a peer. It means that we can finally get to a point and saying, hey, did you make the change to the environment? I did. Did you make a mistake? Yeah, everything is down. I got called at 3 o'clock in the morning. We can start saving ourselves those calls because we can now start doing things like reviews with our peers to say, are we sure this is good? Everybody's happy with it. And we can even take that a step further. We can test. We can spin up an environment. We can run it through a set of validations. We can sit back and say, the review was good. The test has been proven. We are good to go for deployment. And we can keep our 3 a.m. calls to an absolute minimum. The most important point is documentation. Everybody needs to do documentation. Well, good news. You don't have to do documentation because you've done it at the very first step. Your code is your documentation. Sure, it's not written in Norwegian nor plain English. It's written in a language that is specific to the domain we're talking about. So a domain-specific language, or DSL. And in this particular case, we're looking at a domain-specific language that is code configuration for something like Azure or your infrastructure. So documentation, of course, can be then translated. If you think about what we have, this document knows how to tell Azure to do something, or if it's in Terraform, it can tell Kubernetes or AWS or GCP or whatever particular modules you've lit up. But that doesn't mean that your regular team can read it. But it's parsable. There's nothing stopping us now spending a little bit of time automating the process of converting that document into something in Norwegian, converting that document into a graphical illustration, converting that documentation into something that is consumable by others. The choice, utterly yours. The requirement, non-existent. It doesn't have to happen because what really matters is the target that you're trying to configure and maintain has its built document now. this domain-specific language. And because of that, we also get the final benefit here, reuse. I can take this code and I can redeploy it in any other environment, in any other customer, or I can simply look at it and say, that was pretty close to what I need for my next objective, my next solution, my next project. Let me reuse parts of the solution that I've done. So the hardest piece of this curve is getting on board, getting started, and getting into the mindset of building infrastructure code. Once we start, things start to get a lot simpler because we can actually use the snippets, use the learnings, and essentially grow on top of those. And in order to do that successfully, there's a couple of things we want to do. The first thing we want to do is we want to create a library. We want to basically get to a point where if somebody goes to the effort of figuring out how do I actually deploy a website using code? How do I deploy a policy or a virtual machine or a network security rule in code? There is no point in any other member of your team spending a whole lot of effort trying to reproduce that same result. That is redundant. So we need an approach which turns around and says that whatever efforts we've done, we put it into a library. We say, this is my snippet. This is my example. This is my methodology for how to achieve your objective. The document, again, that we're looking at essentially is this code piece, but we can put beside that code a small README file. This particular module's purpose in life is to deliver us a virtual machine. It has a set of parameters, maybe the machine name, maybe the machine operating system, maybe the machine size. These parameters are optional. If you don't provide me those, then we'll get to a point where we always deploy a Windows machine that is of our normal business consumption size. But if you want to customize it, then override the defaults or the optional parameters. That piece of effort that was needed to make reusable code starts the concept of team. It disseminates the concept of my library, my item, my virtual machine, and moves it into our. And that's exactly what we're trying to do here. So I reflected on the point that most of the stuff we're sharing here is based on lots of common knowledge. But all of the common knowledge we've come across focuses on the idea of I've built a test lab. I'm going to deploy this to my environment. I can copy this and deploy it to a second environment and we're good. They all fall at the first hurdle when we try to move them into teams. So hopefully we'll get from here how to make that actually happen. So what are the best practices? What are the learnings that we've come across as we actually attempt this effort? There are a couple, and this list is not exhaustive. There's a few more on the top of my mind that I'd like to add, but in 45 minutes, we're going to get a good stretch to actually cover all of these. So let's take a look from the top. First of all, automation. Everything we do, we want to automate. The deployments, the environments we're targeting, the methodology that we're going to test, how we break the tests down, make them small, modularize. What does that mean? Then I look at these templates and there's 1,000,001 parameters. I have no idea what is a cluster quorum. How do I tell the module the correct answer to that in the right format as it expects? Those sort of things make it much harder to actually consume these modules. So I get to the point to say, oh God, there's like 50 different parameters in the thing. It'd be just far easier to do it the old way. Far easier to use my own template. I at least know what question he's asking. We've output parameters. Why would I bother doing an output parameter? What am I outputting? What can I do with those outputs? So again, let's talk a little bit about those. The approach of scaling and how do I govern inside the cloud? One of the approaches we take is the concept of running one deployment per resource group. A resource group has to have a purpose in its life. Let's talk a little bit about that. Very simple governance and how that will help us make sure that when we build infrastructure that fits into this governance. And that moves us straight into the next 2 or 3 points. Naming conventions. Everybody hates these things. There's no need to hate them. They're actually pretty easy to deal with. And sure, very simple guideline. If you can't close your eyes and picture how the name should be for the resource you're trying to create, your naming convention is too complicated. It's that simple. You should be able to take a look at a resource and deduct from its name its purpose in life. We've been doing it for years on premise. Why is it so complicated in the cloud? And how is it so complicated to make sure that we do it consistently? I'll show you some tricks. Secrets. There should be no secrets. A secret is a problem. We'll look at what we can do. How can we deal with those things? Use a complete deployment mode. This one is a little bit obvious, but at the same time, Azure doesn't tell us it's that obvious. We'll take a look at the modes that are available to us, and we'll explain why we'll go with the different modes and their purpose in life. And the final one I want to cover is versioning. This one is absolutely sneaky because one of the things I showed a few moments ago is that nothing stays the same. Think about your infrastructure as code. Now forget about it. Now think about configuration as code. Think about the fact that I have just deployed a new piece of infrastructure, which is a firewall. Think about that firewall's purpose in life. It's not that the IT guy needs to come and rack a new firewall every day. No. It's that the network guy needs to log into the firewall and update the configuration on it every day. There's a new software being deployed. There's a new rule being added. We need to make sure that we can think about two things here. What version of the firewall have you deployed? Think about your on-premise systems, your Cisco's, your Palo Alto's, your Foundries. They run a software. There's a version number on it. Your Windows desktop has a version number on it. And then inside that, you run your configuration. That configuration gets changed. Yesterday, I didn't allow this particular website out. Today, I do. Did I change the operating system on my desktop or on my firewall? No. So what am I versioning? Why am I versioning? How do I version? Let's talk. So before we kick off into the full list, any questions? And how's my pace? Is my English clear enough and my pace fast enough or too fast?
It's good enough for me, and I haven't seen any complaints or questions in the chat so far. So
great stuff. Okay, and let me ask a second question then. How many of you guys are actually doing infrastructure in code today, or have the ambition of trying to deliver infrastructure in code, or simply couldn't care? You can use the chats for yes, no, don't care. All right, so what do you guys, so we've got a few people out there. Okay, so those of you that are doing it, I want you to be critics. I want you to be very verbal in the chat window. Cut this apart, because by cutting this apart will help us actually to get some of the reasonings behind my thinking, especially if I'm not addressing them clearly. And let's get on with this. So the first one is automate deployments. This thing is one of the very first things we have to do. At the very start of any project, most of the time we start with the concept that we want to actually build a template, put it into Azure, check it, make sure it works. And we'll talk about automating it later. Don't do that. Do not do that. Automate it from the very start. Think about that flow from the start to the finish at the very first step. Why? Because the later steps never happen. I have an objective to get this thing done in code. I'd like to do it in automation, but we'll do that later. In the meantime, I've got it deployed. Things are good. I'll come back to it. You will come back to it. I agree. But at the most inconvenient time in your life, because there will be so many other things going on. And if you had finished the task of automating, this would be a click the button, let's make it so. That moment will not be the case if you don't actually automate first. Now, this is not that hard. Actually, this is really, really easy to do and has become an awful lot easier in the last 12 months with the methodologies that are on the toolings. So what are we talking about? Well, we're talking about the fact that we're going to use the JSON templates for talking to Azure. So I'm going to talk Azure directly. Call me a nerd, but I've tried the Terraform thing. We've tried some of the other solutions. So we're going to go straight into using ARM templates. The concepts don't matter. They stay the same. The tooling doesn't matter. The approach is what matters here. So in our particular case, we're going to basically make sure that we have these deployments set up in a methodology that allows us. So what does that look like? Well, what that looks like in essence is something like this. a dashboard to tell us that all of the changes we're doing has gone green or not, as the case may be. And we'll take a little closer look at why they're not green in a few moments. But what we care about here is the fact that everything that we're doing gets to us a point where we have this dashboard that turns around and says, this is good, or this is not good. And we can quickly do the blame game. I can come over here, I can take a look down here, and I can say, right, we have a problem. What happened? And I can drill into those problems. I can see exactly where the issues are, but far more importantly, I can start figuring out who done the change, what the change was, and give them a bit of a nudge saying, dude, seriously, I need you to get your act together and sort this thing out. Let's take a look at that in a few moments. So how do we make this so simple? Well, all we need to do is create an additional file, which the good news is you only need to create effectively once. That basically says run the pipeline. Now, that sounds simple. And the reality is it is simple because if I take a look at this environment, I can click on edit and I'll see this pipeline snippet that I'm showing you here a moment ago. And all I'm doing is I'm basically saying every time a change happens in my environment, and I mean every single time, I don't care what branch it's on, I don't care what tag it's on. Essentially, every time a change happens, I want to trigger this process. I basically want to check that I made something good. Now, I also want to make sure that I'm keeping an eye on my configuration file, so the specific file itself, and any of the modules that I might be updating in my library. What do I need to do? Well, that's pretty simple. I want to break this down into a set of stages. The first stage is I want to validate it. So to validate, I need a machine. So I'm going to grab myself a Linux machine. I can do Windows, of course, but Linux machines generally are a little bit quicker and definitely a little less painful on the pocket. I'm going to run a pester test. So what does the pester test do? Well, we'll take a look at those in a few minutes when we talk about testing. But in very simple terms, these can do quick checks to make sure, for example, that my JSON files are actually syntactically correct, that my JSON files are indeed JSON files, that my README file exists, and all of the other pieces that I want to have around the place. Once I've done that quick check to make sure things look normal, then I can move on to the actual process of staging. So again, grab myself a machine to work on, and this time I want to version. We'll talk about that in a few minutes. I want to version my module numbers. I want to prepare those modules so that I can actually deploy them. And then finally, when I've prepared those modules for deployment, I can move on to the phase of the puzzle which is responsible for releasing it. And in this particular case, I might be releasing it to an actual storage account, or I may make a decision saying, hey, I want to actually release this directly to Azure. And this is the very first of these changes that you're going to see from any of the blogs you read. They're all going to basically be saying, okay, we're going to release this to the dev environment, release this to the staging environment. And this is the first point where I'm going to say, no, that's absolutely not acceptable. Do not do that. Why? I'll tell you why. Because this is a module library. This tells me how I want to build a virtual machine. Tells me that I want a firewall, but it tells me nothing about how I want my virtual machine configured, what operating system, how much memory, what disk size, what applications, about my firewalls, what IP addresses, what rules. Okay, this is simply the block that is that firewall, that is that virtual machine. So I don't want to put a generic virtual machine in. I want a customized machine in. And as a result of that, I will use a different pipe to deploy to my environments. These are Lego blocks. Treat your modules as Lego blocks, and you're off to a really good start. So the key piece here is every time we make a change, and you'll see it through my history, the second we make a change, we run it through those validations, synthetically correct. It follows the concept of unit testing. Does that module work on its own? Does that module work with multiple modules? Does the module work in a full integration? So I decide I want to actually deploy a test environment with 2 virtual machines, a load balancer, and pass some traffic through, does that full end-to-end integration test work? So we take a look at the different types of tests we can do, modular-based or integration-based, and make those part of this cycle. And I'll show you in a few moments how we actually do some of that as well. So as we go through these different tests, why do we want to do these? Well, we want to make sure that we stay good quality. It's very important. We want to make sure that all of these tests are done by the system. They're consistent. It's not just one engineer making the test and say, yeah, it looks good. We want a consistent validation test the whole time. We also need to be able to provide and share these modules with other users. So by doing these tests, you need to actually create a parameter set. Those make fantastic samples to show people how to actually make these modules usable. So now I'm getting to a point without doing any documentation. I'm already creating the module and the configuration to allow us to validate this thing. You always should start with at least one test, but there is no restriction in how many other different tests you want to run, depending on how complicated that module is. So for example, let's take a module deploys a virtual machine. Virtual machine can be deployed as a Windows virtual machine or a Linux virtual machine. They have different dependencies. So it is absolutely appropriate in that case to have multiple tests on that one module because you've got different mocks or different permutations for the test that needs to be completed. And of course, we want to follow the idea of keeping these things small. When I create a module, I'm creating a module to do a job. I'm not going to create a module that is responsible for doing 2 and 3 different things. So we're going to follow an awful lot of the practices around developing microservices. The idea here is we're going to follow the principle of single responsibility. This module's job in its life is to deploy us an app service. What type of app service? Not important. Its purpose in life is to deploy us a virtual machine. Or what type of operating system? Not important. It is a virtual machine. Take the abstraction that you have from the on-premise physical world. I need a VM. Great. What operating system? I'll worry about that later. Same concept happens here. You won't want 2 different virtual machines, one for Windows, one for Linux. So therefore, you don't want 2 different templates. There's my Windows template, there's my Linux template. Don't do it. You're making your life harder. So how do we do these tests? Well, a moment ago, I showed you in the back end that we run the idea of this pipe every single time. And every single time we run this pipe, I've got this idea of running a set of pester tests. Now, what's a pester test and where do I store those tests? Well, it'll be no shock when I turn around and say that we store the tests with the actual modules. In this particular case, I'm using run pester tests. And run pester test says we're going to use the Azure Resource Manager test toolkit. Pretty obvious idea to start with that toolkit. That toolkit is pretty new. I think it got announced at Ignite last year and has been improving all the time. There are some tests in that test kit that I believe are not appropriate, so we're going to exclude those from my environment. And then we're going to basically load up all of the rest of the stuff that we care about. And then once I've got all of the tests that I care about, which are provided by Microsoft in the open source library for the test toolkits, a link for it is on screen here. Then we basically run that across all of my modules. So I'm basically saying, find all my JSON files, and let's run this test in sequence for each file in that link. And then we'll use the results of those to see if things are good or bad. I'll show you that in a moment. Now, what does the toolkit look like? Well, let's come back here for a second. And I simply just downloaded the module and expanded it. So now I see the full module, including its provided documentation. And I can see even all the different test cases that Microsoft put in. Deployment templates, checking to see all of these pieces. So we can add our own, we can use the ones that Microsoft have, or you can even modify them. The choices are yours. But this is immediately getting us to a point when I run a pipeline that I can actually turn around and validate that, yes, things are good. Run the tests, checking the success, checking the success, checking the success, and every module saying, yeah, all these look good. We are happy. Now, these tests might not be just in doing synthetics. They may not be just checking for rules. These tests can also deploy that module, put it out to an actual sandbox environment, say, create a storage account using that module. Did it work? It did. Validation successful. The choice is yours on how much you want to do on those. Now, with that in place, we have already got a major benefit because now we're in a scenario where we know that our modules are synthetically correct and good to share with people with samples because we've done parameters. Of course, input parameters are good, but output parameters are even better because we are thinking about Lego blocks, and you've all built Lego in some shape or form. These Lego blocks come with little bubbles on the top of them, or might be 4, might be 6, might be 8. There could be 20 of them, depending on the size of the block. And then depending on the size of the block, you make a decision. Can I click that block on top of the next one? And how does that flow work from top to bottom? And the same should be exactly true when we start thinking about building our modulars in DevOps or in infrastructure. I need to pass in a set of information. But at the far side, I need to pass out information. So let's think about a module whose job is to deploy us a monitoring environment, a log analytics environment. What would I pass in? Maybe a name. Anything else? Maybe a list of the different solutions that I want to actually have monitored. But what would I pass out? Well, this one's probably far more important. I'd want to know the resource ID. Where is this monitoring? Because everything I deploy from this point forward, I need to say that is the resource, that's the monitoring service I've just deployed. Make sure that when you're sending your diagnostics logs, send them to that resource. So taking out the outputs in some of these modules are actually far more important than taking in the parameters on the far side. Now, one of the other things that's kind of cool here is that as we start building modules, these inputs and outputs help us to build a depends on pattern. We can't actually deploy that virtual machine because I don't actually have the actual monitoring workspace ID. So the first thing I should do is deploy the monitoring workspace ID, get the output, and then as a result of that, have the input that I need for my next in chain. So if I'm using something like a linked template, Azure will do that. He will take a look at all the templates you hand it, he will figure out the actual order of execution, and he will build those for us. That means we don't need to define it inside the template. It becomes an anti-pattern. It's not something we need to worry about now. Azure can figure this stuff out. But that all assumes you're using linked templates. Different topic altogether. Personal statement on this one is don't use linked templates. I personally never do. We stopped doing it about a year ago. Why? Because they have so many problems when I start thinking about modular testing. I go back to the concept of that every module needs to be a single resource responsibility. If I've got linked templates, it's not a single resource responsibility anymore, because I need to make sure that I have these 3 different templates linked together to get that one solution. Doesn't work, doesn't scale. It makes testing an absolute nightmare. So I will say, don't use linked templates. If you have any opportunity to walk away from them, run. So what do the outputs look like? There's many, many different versions of these. A sample from one of our templates, basically we'll just turn around and say, hey, show me back the resource ID for our web app. Show me back the name of our web app. And then if I happen to be using something like a managed identity, let me know what the managed identity is. And of course, the managed identity belongs to an Active Directory tenant or an Azure AD tenant, so I need the tenant ID as well. So very simply at the end, I've got enough information now to turn around and say if we wanted to do a configuration on the web app or a web deploy in the web app, this is the web app I just deployed. Any questions so far? Okay, well then we'll keep going. My next statement is large modules should be considered as toxic and harmful. What do I mean that? Let's go back to that single responsibility. Keep the modules focused on their purpose in life. If you make them too large, as in this module is able to deploy my hub network with all of the NSGs and the firewalls and all of the pieces in it, then that's just dandy. I'm happy for you. However, you're going to have a major problem when it comes to actually doing code reuse. You're going to have a huge problem when it comes to testing. It's going to be slow and hard to understand. It also doesn't help you when you want to become part of a team, because yes, your module done all of these things, and that was really cool. And I see many consultants do exactly these because it is really cool. I walk in here, I run this template. When I land, go meet the customer, shake his hands, have a cup of coffee, spend a couple of hours chatting, and then come back and say, right, now time to get down to do some work. And well, all the work was done because he hit one template and done exactly what he wanted to do. But the reality is that that template's purpose in life was single instance, single definition. That's perfect for that situation, that scenario. But that means that it's no good to you as the customer to take that for reuse and reuse that code for anything else. Are you going to understand what he'd done? Are you going to be able to diagnose it? Are you going to be able to reuse it, review it, or do anything else? Change it and modify it to your customization? I doubt. I absolutely doubt. So we don't do this. Toxic and harmful, do not allow them. Now, that doesn't mean a single purpose module can't be large. I've got some templates that just deploy virtual machines that could be coming close on 12 to 1500 lines in length. That's fine because they're following the single purpose in life, and some things inside the module needs to be verbose. Don't have choices, so I've got to type the code. But at the end of the day, its purpose in this particular case is what we talk about when we talk about large modules, not the line counts. We're talking about its purpose. Keep them simple. And you should have a library of modules. So you've seen that already in the screen share I was doing a few moments ago. I have my module folder just beside everything else that was on my screen. Let's go back here again. And we'll see the idea here is things get organized into a folder of modules. Pick a naming standard. In this particular case, I'm doing DSC for desired state, Active Directory member domain controller, desired state, remote desktops gateway. Then I've got other ones which start with RES. It's a resource group type template or a management group type template, or down here, a subscription type template, because there are now 3 different types of templates allowed in Azure. These templates are all ARM, Azure Resource Manager templates. So if I wanted to put Terraform in here, sure, I could do an res.tf dot. And then at the end, my naming standard says, what's the purpose? What is the single purpose of this particular template? And here I can see it gives me workbook, workspace, web gateway, virtual machine, user identity. None of these have multiple purposes. They all have a single purpose in life. So structure your team, structure your library to make it very simple so that you can get in there and understand exactly what's happening. And in addition, inside any one of those folders, modules, module name, I also have a README file. The documentation comes in here and says, this is the purpose of this template. These are the parameters. These are the outputs. So it's pretty simple and pretty clear, and this is nothing more than a table of what's on the input. But more importantly, you'll also notice in here, I have that parameter file. Here's a sample. This is what it looks like to provide a jump box subnet, and here's how I would provide a rule, or in this particular case, an array of rules, a list of rules. So that makes it really easy for us to actually start configuring and maintaining and sharing these things. So I can hand over this module to you and feel pretty confident that you're ready to run straight away. So one of the things that we have in templates is this idea of, if I do give you that template and I ask you to work with it, what are you going to do when you open it and it relies inside the environment? He needs you to provide me no less than about 30 different answers. So let's go back to that same template again for a moment. In this particular case, this template's got a set of parameters. It's the first thing that we define at the top of each of them. Tags, network security groups, log retention, storage ID, workspace ID, network watcher ID, flow format, version, traffic analysis, enabled. Oh my God, there's so many parameters. And I'll be honest with you, this is only a short list. But if you look much closer, every one of these has a default value. Default value, default value, no default value. Network security groups. Well, I guess there's no default network security group because that's something that's somewhat mandatory. You wouldn't bother deploying the network security group if you didn't actually want to define what the network security groups were. So in this particular case, that's a mandatory. You need to provide me that. Log retentions, default, 30 days. Storage ID, not optional. We need to make sure we debug. So I need a storage ID. So you get the idea here that as we go through these things, you make a business decision saying, what are the parameters? And are those parameters absolutely mandatory or are they optional? So don't cut short on parameters. Put them in because you will want to flick the switch. However, use defaults where you possibly can that makes things consistent and easy across the environment. For example, we talked about the idea of I want to deploy a virtual machine, Windows or Linux. Let's look at that one for a moment. Switch over here to modules, switch down here to my virtual machines module. You'll see I have one module, but you'll see in the parameters, I have one to give me Linux, one to give me SSH, one to give me domain controller, one to give me some sort of a VPN gateway. What's different? Well, the difference is basically I'm asking you what operating system you would like. It's a default. Don't tell me, then I'll give you Windows. Tell me, I'll give you Linux. And there's enough logic inside the code to figure out that, well, if you ask me for the Linux operating system, then I can then flick the switches over for everything else from the monitoring agents and the recovery agents to actually put the right things in place to make this work for you. So again, you're isolating those to single responsibilities. And you'll see that here in this particular case, my web app, providing a default. And with the default, I can then make a decision saying, what type do I deploy? Is it a function app or is it a regular web app? What environment, what app settings? They're all switching here inside the logic of the module based on the parameter that I provided. And that parameter in this case was optional. Naming conventions. How many people love naming conventions? How many people have a naming convention in Azure? And even if you have figured out a naming convention in Azure, how do you communicate that with the rest of your team? It's a nightmare. And sure, we can put it into a wiki file or a document and we can distribute it and tell everybody that's what they need to do. We could contemplate putting up an Azure policy to do it, but they break. They're unreliable and they basically end up with people turning around telling you that you broke Azure and getting really annoyed with you. And you're happy that you're living in Ireland because they can't slap you. But the reality here is that you do need something that's a little bit more scalable. So follow that single responsibility pattern. And I'm just looking at the comments. Yeah, we should be past the modularization slide. We're over on naming conventions, and I'm about to show you the browser again. Yeah, that's perfect.
Yeah,
so
I think I'm up to date. I'm
just need to switch.
Naming convention. So
yeah, that's perfect. Okay, so we're following the same single responsibility pattern in this scenario. We can actually do this in a much simpler way. We can actually make a module. I have one on GitHub that you're welcome to grab, which basically says, hey, let's make a module whose job in life is to actually implement a naming standard. Pass in some parameters like a company name, project name, and environment. Let's do a little bit of manipulation and then take those and use them as outputs, right? Now, I've built the naming standard by just grabbing the information you passed in. That works. That's a pretty good way. The only problem is this one feels a little bit like a linking scenario, and I don't particularly like doing linking anymore. So that's appropriate, that will work, but there is a nicer way of doing it. And the way I prefer to do it at this point is actually not ask the user at all. So you'll notice in any of the templates that I deploy at this point that we don't actually have any parameter that asks you for a resource name. Because if we follow a standard, we can actually compute the resource name. We have the resource group, we have the subscription ID. So if we use those as the base for our naming standard, then we can actually build the names for our web apps, for our workspaces, for our app insights by concatenating things together. I can start with the basics, I can join them together, and I can end up with a naming standard that is basically built into the module. And I'll show you that again for one more second. If I switch back as far as a module, I scroll through this, you'll notice as I scroll pretty quickly, and you can trust me on this, there's a lot of different parameters, but what is not in this parameter module is a name. We never ask the user to provide a name for their resources, their virtual machines or anything else. I ask them if they're doing a cluster or they need multiple machines, and I use that. You'll see it in all of these things. VM prefix, availability sets. If I'm using an availability set, then add a suffix. If I'm doing a load balancer because I need to be highly available, add a suffix. So I can build and compute the name as part of the actual template. So naming standards while they're extremely important and they're extremely political, you can forget about them because you can actually hide them into the modules. Another good reason to do this. That means you have a very consistent experience. One deployment per resource group. Well, that one is pretty obvious. As we deploy to Azure, we should be just having a resource group's purpose in life is to run a single set of business rated services. So just deploy the app to that. In this particular case, I'm showing you deployment, one deployment, and that simply deploys out the API management services in this particular role. If I need an ASE environment or if I need a web app service, different resource group to host that service. Preferably a different subscription, because something like an API management is an expensive resource. So he should actually be sitting in a separate subscription because I want to share that with other users. Secrets never in code. I don't need to talk about this. We all know secrets should never be in code. But I did make a promise a little bit earlier that I would show you what it looks like if you make that mistake. And I am not immune to not making those mistakes. So I'm going to come down here and I'm going to find the pipeline we ran a moment ago, which was my infrastructure pipeline. So it's sitting up here. And if I spin down, I will take a look at this particular fail, and I'll put my hand up and say I'm guilty for this particular deployment. And in this particular case, I can see output contains secrets in the function key. So I click on it and I can see the actual failure. So that testing that we said, that testing is enforcing security now. So now all of a sudden I'm getting full loop, my full life cycle starting to kick back into place here as the environment takes care of what's happening. So as we do our templates and we look at the outputs, we can use the test toolkit that I showed a little bit earlier for checking things like our template to make sure that we're passing them in and out properly. We can also go the other way. What happens if we're passing in parameters? I'm building a Windows virtual machine. In that Windows virtual machine, I want to pass in a username and password. I can actually have Azure say, go to the key vault, grab from the vault the SSH admin name and the SSH password. So again, I never expose these things. So what am I doing in the test toolkits? Every time I see a requirement for a secret to be passed in, I make sure that I'm setting those in to come in as references. And if they don't come in as references, I block the deployment of that particular module or the configuration. So finally, we want to look at the concepts of deployment mode. Azure has the idea that he can do incremental deployments. And the idea of incremental deployments is around this theory of idempotency, this fabulous big words that Microsoft suggests and most of these cloud suggest that if we make a change, the change should be the same every time. It's the utopia of what we try to do with infrastructure as code. It's why we start this process. If I give you this code, you should be able to run it. It should deploy consistently, repeatably, every time. It also should be smart enough to say, if I deploy this code and there's nothing changed, then make no changes. If the setting says on and the setting is on, then we just look, we stand down, and we forget about it. Think of it like desired state. We get the current configuration. Has it changed? No, we're done. Has it changed? Yes, we set it to the new environment. That's the purpose of a desired state. That's the purpose of idempotency. Behind the idempotency here in our templates, the default positioning is that as we deploy a module, it will be idempotent from the perspective of what's defined inside the module. So if the module turned around and says, hey, I want us to have SSH turned or SSL turned on for this connection, and it's inside the module, then absolutely he will do that. But what happens if I go into the code and say, well, there's a bug in it and it's not working correctly, so I'm going to remove that particular switch. The next time I deploy, idempotency is actually not going to come into play, because when he takes a look at it, he's saying, well, nobody's actually asking anything about an SSL anymore. So the default current configuration is that it's on, because that's the last thing he asked me to do. He's not talking about it today, so I'll just ignore it and I will leave it on. That's not exactly my objective here. My objective was, when I deleted the thing, that I will put it back to the way it was by default, which was off. And the only way to get it back to default is by using the complete base deployment, which simply says, take the resource, virtual machine, website, wherever it is, delete it and give me a new copy of it. That sounds a little bit aggressive, but remember, we're dealing with the world of cloud. We're dealing with the world that when we make these different types of changes, We want to be in a scenario that allows us to be fully idempotent and allows us to also be at the point that any piece of code we deploy will always deploy as a consistent delivery. So therefore, the recommendation and best practice is that you run with complete in your deployment modes when you actually run your Azure configurations. And then finally, the very last one goes to infrastructure versioning. All of the templates that we do, all of the code we write are versioned. Think about the idea that we spoke about a few minutes ago. I have a firewall. The firewall has got a firmware on it. It's version 5.0.1.13 or whatever the case may be. The same is true for everything I deploy in Azure. Sure, we've got Azure Firewall v1, Azure Firewall v2, and all of these things. That's not what I'm talking about. What I'm talking about is the version of the infrastructure you've deployed. You've deployed a firewall who happens to have 3 network interfaces. That is your firewall version 1. Date stamp it today or use semantic versioning, I don't care. If you come back in the morning and say, crap, I need an extra network interface in that firewall, then you have modified the firewall. Your infrastructure has changed. Now I have 4 network interfaces. That gets semantic versioned or date version to the next version. Personally, we date version. So it's 2020 06 10.01.02. Third update today is 03. So we only make the changes to the version number when we actually change the physical infrastructure. The second piece that we change is the configuration. Sure, once in a blue moon, I might add another network interface to the firewall or give it a new public IP on the firewall. But in the configuration, I could change that multiple times a day depending on how many tickets are coming in. So I want to make sure that the infrastructure, the module from our library, has one version, and the configuration that we put into that module, the parameters file, has a second version. And that needs to get baked directly into the environment. But what I don't want is my humans to be responsible for putting the version numbers in, because if they are, well, what's going to happen? Nothing, absolutely nothing. So in this particular case, the pipeline is going to run. And after I finish my validation, the very first thing I do is I say, right, okay, we've got valid templates. Let's update them with the current build numbers. So in this particular case, you can see this is built on a VM DSC, so a test branch or a feature branch for adding DSCs to a virtual machine. The date stamp says that on 2020-05-31, first build of the day, we're going to actually put that into the modules. So all the modules are built and released with that version. As I then take those modules and I combine them with the configuration and put them into Azure, I can come back to Azure and I can look at the configuration tag and the ISC tag and say, well, what module did I use? That's okay. So that was built with the modules on the 27th of May. That was built with the new test modules that I was doing for log retentions on the 5th of May. And I haven't updated it since. It's good. No changes needed. Idempotency's kicked in. He's turned around and said, look, nothing's changed. I'm not going to make modification to it. The configuration version, it's a test configuration. It's not date stamped. If that was production, that would absolutely be date stamped the exact same way as the infrastructure code. And I want to illustrate that because as you test and produce your code, you will have these versions. And those versions should all be done through these code steps. That's it. That's what I got. Those are my best practices. If there's any one of those you want to drill into deeper, understand more about it, please reach out. If there's things that you think I've missed, I'm absolutely eager to hear what those are. My contact details are on screen. And at this point, if anybody's got questions, here's a really good opportunity.
Okay, let me just stop the recording first, like this.